All right, thank you for attending. This is Clinical Quality Language. My name is Bryn Rhodes. I'm the CTO of Dynamic Content Group. And I also participate pretty heavily in the CDS and CQI work groups in HL7, where we are working on this and other FHIR-related standards. So I'm going to jump right in to a diagram. This is a diagram that we include in many of our implementation guides. It's an illustration of the quality improvement ecosystem. It's intended to show how evidence-based medicine progresses, ideally by research that drives guidelines developed by professional societies. Those guidelines are then interpreted as decision support that ideally impact clinical care. Those decision support interventions and enablements are potentially tracked through measurement and analytics to try to understand what did happen, were the outcomes and processes that we're going for achieved. And then that's informing quality reporting, public health reporting, safety event reporting. And ideally that goes back into the research. And that kind of closes a loop so that this is a feedback and feed forward loop for continuous quality improvement. So one of the things we are working to enable is how do we improve the flow of information and knowledge through these different areas. So if we take a look at something like the CDC's opioid prescribing support guideline. This is recommendation 5 from that guideline. So it's a fairly concise, clinically relevant statement about dosage of opioids and how that guideline indicates that risk of overdose should be monitored. There's a corresponding quality measure that's related to that. It says the percentage of patients 18 years or older who receive opioid therapy for 90 days or longer with no more than a 7-day gap with a daily dosage of 90 morphine equivalents or not, or more. So that's that same 90 milligram morphine equivalents per day showing up in a recommendation from a guideline as well as a quality measurement. Then for public health reporting, there's a detection of opioid substance or metabolite in a clinical specimen by any method. So this is related, and you can imagine the same sorts of value sets and terminologies used to characterize opioid substance or metabolite in the decision support as you would in the quality measurement and so on. There's also research studies that talk about those same concepts. So they take different perspectives and different flavors of these concepts and ideas, but they all clearly relate to that same content. And then you can take any given guideline and you can come up with the same type of reflection of that guideline at these different points along this ecosystem. So the challenge that clinical quality language is hoping to help address is to enable the creation and distribution of computable knowledge at those different points within that ecosystem. There's huge amounts of guidelines and content that are being created, and it's a constant struggle to maintain and keep up to date and implement the content that's coming out. So one way that we're proposing to help address that is by providing this formalism that is clinician domain expert friendly, gives a way for domain experts to participate in crafting that knowledge, It's clinically focused, so it has facilities for expressing ideas and concepts that are ubiquitous in this domain and not necessarily addressed in other formalisms that are available. But it's unambiguous. It can be machine interpreted. It's also platform and technology independent, and it's sufficiently expressive to support the types of knowledge that we want to address. So from a timeline perspective, the CQL has been in development for quite a while. It started in earnest around the close of the Healthy Decisions Initiative in July of 2014, but it built on what Healthy Decisions was doing in terms of the knowledge artifact specification, which was a specification for distributing decision support rules as machine readable format. The Clinical Quality Framework Initiative then picked up where that left off and started building a human readable syntax on top of that machine readable format. So throughout that process, there have been pilots in various areas like pharmacogenomics, Zika management, pilots in the CQF space around chlamydia screening and breast cancer decision support. And then we've published pretty much yearly STU releases. And most recently, we submitted the normative STU4 mixed ballot for the 2020 May cycle. And we've continued growing the community and the number of projects that you see CQL being used in. And so to that end, this presentation is about where all the different places that it's being used are, with a particular focus on usage within FHIR and how you can use it with FHIR directly. So just a quick language overview. It is a declarative language, not imperative. So we're focusing on what, not how. It has no procedural constructs. It's an expression and / query language, similar to the expressive capabilities of something like SQL or XQuery. It is functional. There are no side effects. You can't assign variables or values to variables. It's a clinical domain-specific language. It's not specific to any particular clinical domain, but it has several characteristics and features that support usage in clinical areas. It has specific designed independences. In particular, it has platform independence and data model independence and data location independence. We're not concerned in the CQL with where the data lives and how you actually access it, though there are aspects that are part of the design, and we'll look at those, that make it possible to use in different settings. And it's also complete for certain definitions of complete from an algebraic perspective, a temporal perspective. We have a complete set of interval operations. And from a relational perspective, it's complete in terms of being able to do all the things you would expect to be able to do with a relational algebra, for example. A quick overview of the specification. It's kind of layered into an author's guide that's focused at the conceptual level. It's intended to be a self-contained introduction focused at the people that would be building things like quality measures and decision support rules. Then there's a developer's guide that's a more in-depth look at the language for those that would be more familiar with something like Java or C# or SQL. And then there are the formal specifications for the logical and physical representation and the intended language semantics. And then there's a reference that's just a complete reference for all the operators and functions that are available. So just a high-level view of the architecture overall. The specification describes a syntax for human readable, and a expression logical model, which is a description of basically the abstract syntax tree for the content in CQL. And that's the target for distribution. And the intent is that it's focused on language processing applications such as executing as native or running it in JavaScript or translating it to something like Drools or SQL in order to get implementation in an environment that already has an engine for running logic. So jumping into a specific example, this is a first example. And you've got a library declaration at the top where you can specify the name of the library and a version. There's a using declaration where you specify what data model you're using. This tells the CQL what data types you have available, what resources you can access. There's dependencies, so you can say I reference other libraries of CQL, so I can include something like FHIR helpers. Then there's a terminology section where you can reference terminologies, so you can give a URL for a terminology, a name that you can then use within the expressions to access. And then there's a context where you specify that this is written from the perspective of a patient. And so all of my expressions are with respect to a particular patient. That notion is similar to the idea of a compartment within FHIR. So this is a simple example of referencing a patient, and then you give it that alias P. So that's a query that you can then use that alias to talk about that value within the query. So I can say that the gender is male, and active is true, and the birth date is 30 years before today, and they're not deceased, and the marital status is in marital status. So there are lots of different pieces going on here. One for code valued attributes that have specific required bindings in FHIR. You can just use the straight representation, the straight comparison to the string code. You can, for things that are Boolean, you can deal with those directly as Boolean values. There are timing phrases where you can use things like years before or after or on or before to give indications about relationships between dates, date times. You can also use intervals there. And choices where the deceased attribute is actually a choice of Boolean or date time. But because I've used it as a Boolean here, the translator uses that representation. If I had said we're deceased 1 year before today, then it would treat it like a date time. And then for terminology elements, you can use terminology operators and compare them to value sets. So digging a little deeper into terminology, you can declare code systems, value sets, and codes. And those all have names that you can then reference those by. These two expressions are references to particular resources. So this one says, give me observations that have the tobacco smoking status code, and the status of those resulting observations is in final or amended. And then this lung cancer diagnosis one similarly give me conditions where the clinical status is in condition clinical status codes as defined by this condition clinical, and the condition is in lung cancer as defined by this lung cancer value set from the VSAC. So that's a platform independent but focused on FHIR representation of that. So given that it's actually going to need to be executed at some point within FHIR, that would actually be represented as a query against observation. So in this case, the observation is to patient. Remember, we were in patient context, so this patient is, provided by the evaluation context, and the code is in that like code. And then you want to align those retrieves with documented search parameter capabilities. So what we're doing here is aligning with the shall support for the US core smoking status profile that you can search along patient and code. So I know that when I've written this, I can rely on a server using US core or conforming to US core to be able to answer that query. The next example for retrieving by value set, same idea, but in this case, the search parameter is a should, and implementations might not support that, right? So that needs to be a consideration. In this case, the search is also by a value set. So this terminology would be expected to be available on the target. Now you could inline the terminology to avoid that, where you actually say code equal and then inline all the descriptions of the codes. And there are some engines that actually do that now to avoid that terminology distribution. But you can make a decision about whether that needs to be supported in a given implementation. All right, so other aspects of using this with FHIR. This is an example that illustrates use of slicing. So the blood pressure profile defines specific slices in the core FHIR spec, slices of the component that you can use to characterize the systolic and diastolic components of that blood pressure. So you can use this let to pull out, as the name systolic BP, the actual component that has the code of systolic blood pressure and the diastolic BP, so that you can do calculations directly against those. So that's an example of using slices. And the same idea with extensions. You can actually define an alias for the extension, pull it out of the extension element, and then be able to reference it directly. And for complex extensions, you can build these lets to say the race is the singleton from extension. The OMB category is the extension of race for OMB category. And detailed is the extension of race for the URL detailed. And then you can reference those within your where clause to pull those out. So one of the things we played with at Connectathon 24 was actually having the translator perform these mappings automatically. So if you use these established patterns to access slices by name or extensions, then you can imagine a model that exposed those directly and would let you then write something like this, the same expression, but I can say, give me observation BP, a reference directly to the profile, where the model would be informed by the description of that profile. And so this is happening under the hood, but what's surfaced to the author is just BP, systolic BP, less than 140. And similarly for extensions, the profiles describe the extensions, and so you can imagine using this pattern. This is what's happening underneath, and this is how the CQL is actually written. All right, so I'm going to pause right there. How am I doing on time? And are there any questions at this point?
Hey, Bryn, there's a couple quick ones maybe. One was asking about CQL engines available as open source, and I typed in the DBCG CQF ruler as well as the clinical quality language CQL execution one. Do you know of any others?
Yes, so there's a slide at the end that has a link to a community projects page that we maintain, and there are several. There's several contained in there. All the open source ones that I know about are maintained on that community projects page, and you know, welcome to add any that I don't know about.
And then I think you covered this, but a question here. How can you cover the large variety of ways patient clinical data may be represented in different FHIR implementations? Does it require data to be adhered to or transformed into specific profiles? I think you kind of covered that, but maybe not quite.
Yeah, I mean, specifically the expectations for what data elements are going to be available and how those data elements will be represented would be expected to be characterized with FHIR profiles in the same way that it would for any other application. Whether you're writing, you know, JavaScript or Java or you're making some expectations, you're making some assumptions about what that data looks like, and that's what the FHIR profiling capabilities give us a way to do. Make sure that on both sides of any exchange, we have a semantic understanding of what the expectations are. So that was really kind of the point of the previous couple slides in saying that you know, when you are writing CQL, you're making assumptions about what kind of data is available and what kind of, you know, searching capabilities are available when you're accessing a retrieve. And so those need to be characterized in the same way that they would for any clinical application using FHIR.
Okay, there's a couple more, but I have a feeling you might get into them, so I'll ask them at the end if we don't cover them.
Okay, sounds good.
And you've got just about 15 minutes left.
Okay. All right, so that's kind of a whirlwind of what CQL looks like, and I want to talk about some of the tooling that's available for when you've authored CQL and how you can plug that in to different pieces. So in particular, there's a library resource in FHIR, and one of the use cases for that resource is to package content and make it available in a shareable way, and kind of associate the publication metadata that would be expected to be available for that. So there's specific ways that you coordinate between a CQL library and a FHIR library. In particular, the URL for the FHIR library is the base URL of your implementation guide plus library plus the name of the library. And that's a required conformance. If you're using a CQL library, the name in the library has to be the same as the tail of the URL, because that's how includes are resolved within a FHIR context. Next, the version has to match, right? So your version has to be the same there, and the actual name of the library resource has to conform across those things. And then you'll notice this content ID with an IG loader dash, and then the name of the CQL file. And what that's doing is actually instructing the publisher to take the CQL and translate it and load it into the library as content. So the way that happens is you use this binary adjunct capability of the publisher. You set the parameter of path binary to your input CQL folder. And then you use this ID to say this library resource uses this CQL file in this folder as its source. And the publisher will, when it processes this resource, pull that in and perform that translation. In addition to the translation, it's actually going through and doing semantic validation, reporting any errors that it encounters as errors in the implementation guide. It'll base64 encode the text CQL and the application ELM XML or ELM JSON content, depending on your options. It'll extract and set related artifacts based on the includes. So it's referencing other libraries. We'll look at that a little bit more. Extracts and sets the data requirements based on those retrieves. So anything that you're accessing within the CQL is surfaced as a data requirement in the library. Any parameters that you use in the CQL, as well as the output of that are established. And then the context, and this one's actually in italics because that's a feature that's in progress. But the rest of these are functional today. And I don't know if you noticed, sorry, I should have called this out on the slide, but in the, if you look at that URL right there, sample content IG, that is a functional implementation guide that you can run all these examples and see them working. There's also an options file. So there's a documentation of that format there. But the options file lets you say whether you want to include the XML or the JSON. There are several options you can pass to the translator about validating units or what error level you want the translator to report. And all those are documented there. But if there's this CQL options file in the CQL folder, then the translator will use it to do the translations. You can also reference shared libraries. So the way that works is you say in your implementation guide that you depend on an implementation guide that contains some library you want to reference, and that namespace of that it's the package ID for the library for the IG you're referencing. That namespace is then available as a qualifier. So I can say include example.fhir.uv.myig.example and call that test. And that actually references the library that's included in the NPM package for the implementation guide that it downloads. There's also a narrative template for the library. So you use a path liquid and say that your templates folder is here, and there's a library liquid in that same. There's one in the sample IG that does this. So it takes all of the content that was inferred from the CQL and established using the related artifacts, parameters, and data requirements elements, and puts those in the narrative for the resource. So some tooling that's available. There's a plugin for the Atom editor, that you just add the language CQL. If you go to Atom.io, you can download, that's a simple open source text editor. And we have a plugin that does syntax highlighting, error detection, and translation to ELM, as well as evaluation and testing. So what that testing looks like is you set up a tests folder that's a peer of your CQL folder, and for every library, you can have a folder named that library, and then folders within that library are the names of, or the IDs rather, of patients. And so I can, in that first example, I have a patient example, and I can right click and say execute that CQL, and it will actually run through all of the expressions and evaluate those based on that content. Note also the vocabulary folder there. You need the code system and value set resources in that folder to support any terminology references that are used. So you can define any number of test cases here, and then it will run through each of those test cases for each of the expressions defined in the library. Other ways to invoke CQL directly, we've been working with and defining a CQL operation that you could invoke at the base of any of a FHIR server, where you would be able to just give the expression as a CQL expression there. And there are a couple parameters and operation in that operation definition that's documented there. And this would return the observations for a given patient as a search set, just as if you had done a search against observation. It's going to return based on the result of the expression. And so there will be, if it's returning primitives, it'll come back as parameters. So there's also a library evaluate that says, oh, sorry, that's supposed to be evaluate. I'm just now seeing that. I don't know how many times I went through this. So you can say for this library retrieve example, evaluate with the subject of patient 123, and it will evaluate that library and return parameters output with the results of evaluating each expression in the library for the given subject. So those are some examples of how you can evaluate and use it within FHIR server. So back to kind of where this has been used, we've seen significant usage in the representation of this particular guideline. All 12 recommendations have been characterized using CQL. And we've also, in particular, this recommendation number 5, which turns out to have some pretty complex calculations required to get the MMEs per day. And because that calculation is platform independent and model independent, we can actually use that in the same way, but against, as part of an ECQM. So this is a pre-rulemaking ECQM for potential opioid overuse, and it references that same code that was developed as part of the decision support. So we see how we can actually start sharing logic across those domains. And this is kind of an overview of where we've started to see CQL being used in quality measures, in decision support, in clinical guidelines. We've seen it in both annual update measures from CMS as well as HEDIS measures from NCQA. We're seeing in the CDC's opioid prescribing guideline, as well as WHO with antenatal care and family planning and sexually transmitted infections. And this is just kind of a depiction of, given the base specifications of FHIR and FHIRPath and CQL and CDS hooks and SMART to enable decision support integrations. These are the types of content IGs and specification IGs that we're seeing. And finally, for the resources, obviously the specification itself is there. Note that if you go to the publication history, you can see the normative balloted specification. And if you're interested in tracking that reconciliation, we do that on the CDS working group call on Wednesdays. There's a significant amount of education here available. There are lots of intro webinars that you can read there. There's also Cooking with CQL that we do a monthly call and invite participants to provide examples that we then work through on the calls. And there's a link there to all of the previous examples that have been worked through. So there's a wealth of information there. As I mentioned earlier, there's a community projects page where we try to maintain and keep track of everything that's everything that we're aware of, and a Zulip stream where we invite discussion and provide some announcements. So that is my presentation. Are there any questions?
I think a couple you answered, asking about sandboxes and trying this out, and I think you showed us some techniques, and these links might answer that. But there's a question here about how did the CQL implementation stay in sync with clinical guidelines evolving over time? So maybe you could speak to that a little bit.
So in the same way that you know, we version any kind of content, you have a you know, specification version. You maintain and release new versions of that over time. I think one of the key things to track there is the dependencies and being able to understand the impact of a dependency change. So if you look at these content IGs, we're suggesting the same type of versioning that's used for specification IGs. You have a currently released version, and you have you know, a version history that would let you release new versions while maintaining a stable version. And then when you take a dependency at a version that you're working with, and then you can decide when to up version. So we're not suggesting that that's an easy problem or that it's solved, but we do think that we have the same version control mechanisms that are widely used to manage those types of change.
And I think you mentioned the cooking with CQL. There's a question here around how you would query using criteria on referencing resources, for example, patient with a blood pressure observation greater than some amount. You know, I think you mentioned it. I don't see the link here, but that cooking with CQL. I think there's a GitHub repo that has a lot of examples as well that could show kind of some of those instances.
Yeah, so within the CQ framework organization, there are a lot of repositories that have different examples of decision support, quality measurement. A lot of the examples that are used in this presentation are taken from some of those projects. So.
Okay, I think, are we out of time, or do we have time for one more question?
Could probably do one more if it's quick.
So one question was about the results returned from CQL expressions. And I don't know if you got into this kind of that and the composability. I think we saw when you did that little test run, we could see the outputs of the expressions. So the question's like, what are the results returned by CQL? And then, you know, maybe even think about the composability of CQL expressions in that response.
Yeah, so it's kind of hidden here, but you can see that you can, you know, once you've defined an expression, you can then reference that expression in further expressions, right? So this most recent smoking status actually references this smoking status observation. And so the result of any define is just the result of that expression. And that can be a primitive, that can be a list of resources. You can use queries to shape output, and so it can be a list of any structured result. And you can see, some of these are observations, some of them are lists of procedures, some of them are just null, some of them are true and false. This one's a quantity, 64 pack years. And so depending on what the result of the expression is, it will come back as that value. And note that in the output here, we actually characterize the type of each of the expressions. So this smoking status observation, it returns an observation of 0 to star. If you try to return something that isn't a FHIR serializable result, then that's that is an error that the publisher will complain. But that's only an aspect of using CQL within FHIR as a conformance requirement to say all of your top level expressions have to return things that can be described with FHIR resources.
Or FHIR data types in the case of true false, I guess.
Yes, and those will come back as parameters with that name. In the case of the direct output, this one, if you actually just returned 1 or 2, it would wrap it in a parameters so that it could return it.
Right. Okay, I think that's all the questions. So I guess I'll hand it to the hosts.
All right. Well, thank you everybody for attending, and thank you, Bryn.
Thank you.